same kind of outcomes, right? We're going to go through these CMFs. There's lots of information here. Are you understanding why this is typically a 6-hour course? Lots of information. If you know who's in your audience before you show up, you can cut certain things and add certain case studies and things like that. I think I got my list a few days ago. So, and we have a wide range of folks here, everything from DOT to city, county, regional trainings from all over the country. So what's of importance here? 20% of roadway fatalities are at unsignalized intersections. Nationally, 2016. We've got a good chunk of ped crashes, those keep going up, and bike crashes, and about 27% are at all intersections. So what does that mean? Not a lot of fatalities tend to happen. Why are there less fatalities, do you think, at signalized intersections? People don't, what's that? Could be slower speeds because of where they are. Everybody's stopping, theoretically. Again, unless they're doing something wrong, right? That's a whole nother situation, the run through red. So roadside too much. So we have rear end, angle and turning, side swipe, and peg crashes. We mentioned in signalized intersections, right, that your PDOs and your rear end collisions may go up. But your angle ones may go down. I was just going to look at some statistics here. So that you need to recognize that sometimes we're making decisions based on the type of crash and the severity versus all crashes. Because your crash rate will go up when you do a signalized intersection. Very complex situations, lots of users, lots of different traffic control for unsignalized, which is what we're talking about, and then lots of 3-leg, 4-leg, 5-leg. This is a 6-leg. There's all kinds of different things you can have at unsignalized intersections.
Where's that lower one at?
I have no idea. What would you do here for a safety improvement? Roundabout. Yeah.
You already have enough asphalt.
You certainly have a ton of asphalt. Yeah, you probably already have the right-of-way. There have been studies on converting from 4 to 3-legged. We do know, again, more conflicts, right, at 4-legged intersections, 1.2 to 1.6 times those at 3-legged. And we know that, or the research has shown that safety at offset 3-legged intersections increases as minor road traffic increases. What this graph over here shows is basically crash rate with regard to minor road traffic share. And you got this one up here for the 4-leg and this one for the offset 3-leg. And it just shows that gap getting bigger as the percent gets higher. There is something in the highway safety manual related to this kind of conversion. And that's this slide, okay? There's a little bit of documentation out there online about converting 4-leg to 3-leg. Now, as the designer, I want to make sure that those things are far enough apart that they're not interacting and that I don't have a lot of through volume on my minor road. There's percent of minor road traffic, and then there's through traffic on your minor road. So all this really is saying we're taking the number of conflicts down, and now we're separating them. You can also bring them together. What does this impact? What operationally does this impact when you do this kind of conversion? What does it increase? Operationally. Delay. Delays. I mean, what I'm talking about is operations. So there's operations parts to this too. There's delays and things like that. And there's a difference between this design and if you were to flip those. Okay? It's about where you're turning left and where, turning left off the main road this way. You're turning right off the main road this way. You're turning left on the main. See what I'm saying? It's about where you're turning left on and off. And so all this matters. So we're simplifying this in a lot of different ways. But 25% reduction in all injuries in an urban area for specific situations. Sometimes this matters if designed properly and correctly. Okay. Lots of treatments we can discuss. Does anybody have anyone in particular they want to discuss? Because we got time. I'll just kind of clip through them like we've been doing. The very last one? The last slide.
Did you say that if you're going to convert it from a 4 to 2 3s, 4-way to 2 3-ways, you want to do it this way, you don't want to do it the opposite way?
It just depends on what you want to do.
You don't want the left turns over that.
If you do the opposite way, yeah, you'll have that problem with
You don't want the left turns.
Right. They got to be far enough away. Yeah. If
400 feet.
At least, yeah.
depending on the design and which way they go. Yeah, it's all related. Yeah, I understand what you're saying.
I would think if you're moving it that far, that it'd be a pretty
Yeah, it's
hefty
expensive
project.
to move
Pretty
the
hefty
road that far.
project.
Well, yeah, and we may or may not be talking about low cost here either. When they did this study, it was my understanding that they didn't kind of split it out between the two different designs, but just from an engineer's, if you will, operations design person's point of view, I know there's a difference between this and this, right? Yeah. There's that four-way again. It's supposed to be all-way. So this is in the highway safety manual, minor road to all-way, 75% reduction in angle, 48% in all. But again, specific situations, right? MUTCD has warrants and things like that for this kind of thing. It's not just everywhere. So it's reducing this kind of crash, it's moderate volumes and balanced volumes, and being selective because delay and things like that change too. There's operational trade-offs for this kind of thing. And then we have way too many unwarranted stop signs out there in this country, in my personal opinion, including somewhere where I was over Thanksgiving back at home in a very well-established neighborhood. I still don't know why they got hundreds of stop signs in that neighborhood. And I've never gotten a decent explanation for it. They're trying to slow speeds. Meanwhile, I'm trying to figure out how to get through my old neighborhood as quickly as I can by avoiding as many of those stop signs as I can. And then rolling through it. Oh, sorry, I shouldn't say that. What's that? All those kids are going to die. And all the people driving in this neighborhood are all the same people. And they all know that there are kids around and the proper speed. So I did ask, actually, the engineer at one point, because I made the same speech, and he happened to be in the audience. He came up and said, "You don't like my stop signs, huh?" And I said, "No, I really don't. I don't think that nothing's changed in that neighborhood. Volume's certain." And he said, "I've got to have them so that the police can tell someone who's at fault when they hit each other at slow speeds as they're, slowing down." And so, of course, I talked to the police, and they said, he kind of laughed and chuckled a bit and said, No, if I want to give someone a ticket, I can figure that out all on my own. But the two people that are probably hitting each other are also two people that know each other because they're living in the same neighborhood that's very well isolated." So, yeah, anyway. It's one of these things where people start not treating stop signs with respect because we put so many of them out there. Roundabouts, I don't know that we really have. I mean, this is lots and lots of huge percent reductions, right? Oh, sure.
So are you telling us that four-way sign, that's not used anymore?
So as of, I think,
Say all-way?
so I think, yeah, 2009, the shall was you shall use all way, that you shall not use two-way, three-way, four-way, is actually a shall not, which is unusual in the MUTCD.
Those don't have to be replaced immediately, just after a useful life. Is that correct?
It's all about that first chapter of the MUTCD and how you follow it. And in the first chapter, it talks about what you're talking about. Yeah, it's not like you got to go out and change everything. But if you take it out and you don't have a all-way and you've got something else that still moves, then you have to add another sign that says traffic from the right doesn't stop or something like that. It's a yellow sign at this point. So, yeah, you'll have to read the MUTCD or we could go do some training on it. Big percentages in the highway safety manual for roundabouts, from stop control to a modern roundabout. And then this one's on a high speed situation, 87% reduction. Again, huge percentages, rural, urban, yeah.
Is there a volume limit to where you consider a signal instead of a roundabout or like a limit traffic?
So I haven't done any kind of training in roundabouts for some time. You can get pretty high volumes through a roundabout, particularly if you're going multi-lane. I've got 3 right near my house that, not multi-lane, but lots and lots of traffic flowing through those. The only place I've ever seen a signalized roundabout, and I know what you're saying, but at some point out in Germany, at one point, the volumes got so high on their roundabouts that they started signalizing them. And it's really quite a dance when you try to signalize something that goes in a circle. It's really quite incredible. The J-turn, I call it the J-turn. I know it's our cut now. The R-turn, R-cut, U-cut, restricted crossing U-turn. Mr. Joe Hummer used to call it the Super Street intersection. He was out of North Carolina. I don't know where he is now. But this is where you get rid of this on essentially a divided roadway expressway. These are not in the highway safety manual, so we added those stars over here on the left, but you're getting into 34%, 53% reductions in rural areas. I've proposed one of these on a road safety audit on an expressway in Wisconsin. People had died, they put it up, everything's fine now. It's all about doing it in the proper design, using Green Book focus, putting it in the right places. You're getting rid of the left turns out and the throughs, and it has an impact on safety.
All discussions so one of the concerns is in agricultural areas, is a tractor fleet. That is all the commercial areas. Right. Is there any guidance? Rob, not your areas. We have some agricultural areas, we've got some logging areas in the state. Those vehicles making those U-turn movements. Some of our engineers are concerned about the delay and everything.
As they should be. He's talking about larger vehicles making the U-turn and then having to accelerate back up to make that right turn here. And that comes up in Iowa too, and it's actually kind of dampened things a bit. There is some guidance. I know again there's again the Green Book's starting to talk about it now, and they talk about the loons out here where you actually have a little bubble here, right? And so they're literally crossing that and then accelerating on the roadside there. So it's all about how much area you've got, right away you've got, and what you can do, and then making that engineering decision, right?
You gotta build that out, that actually,
And if you get into plowing areas and everything else, do you have any comments on it? You got those in Minnesota, the J-turns. They tend to work well if they're designed well and in the right location. But yeah, logging trucks, agricultural equipment, just regular motor vehicle, large commercial trucks. Yeah. This is on high speed, by the way, these percentages. And then you have the Michigan, what I call the Michigan U-turn. I lived outside of Detroit for a long time. I went through lots and lots of these intersections. It is different though, remember, that they're still allowing the through movement here. But if you want to turn left, you're doing this kind of thing. So you're getting rid of some of the conflict in the main area. They did a bit of a synthesis and found a 30% reduction in injury-related crashes. What I did want to mention is in the highway safety manual, there is, let me make sure I got this right. So in the in the CMF clearinghouse, you can do J-turn, you can find that. You're not going to find M-turn or Michigan U-turn as far as I can tell. But there are 7 CMFs which are in the highway safety manual for moving left turns away from the minor approach to a U-turn. And it's all about whether that applies to the situation that you want, that you're doing. Okay, so moving left turns away from the minor road. This doesn't move the left turns away from the minor road. It basically makes you kind of do this. There's all kinds of different options at this kind of situation. You're basically just doing crossing here, and everything else is going around at these U-turns. And those are big, this is Michigan, so these are big, wide U-turn areas where sometimes people stack up next to each other, which is a little hairy and scary when you're going through there. But they tend to work. Oh, there's a picture of it right there.
I would note, we did one in Indiana, first one about.
Like the Michigan U-turn or the
It
J-turn?
was an R-cut.
The R-cut.
3 years ago, we had multiple fatal and high injury crashes prior to that. In the 3 years after, we've only had 2 minor crashes. In addition to that, in the area, traffic volume has grown about 2.5%. However, at that intersection, we recorded a 14% increase in traffic volume.
14% increase in traffic volume.
In traffic volume.
Yeah.
And a lot of it is trucks. Commercial vehicles are preferring to turn left at that location versus other locations.
Okay. And what we had in Wisconsin on this kind of expressway situation was people, even though they could stop in the middle, not wanting to stop and losing people in the backgrounds and it was a cut through for the high school kids, and yeah, people were dying. So high-speed situations. Okay. Left turn lanes in the highway safety manual, big percent reductions if you add left turn lanes. There's reasons we add turn lanes that are not just operational. So this is out of a Harwood study that was done and made it into the highway safety manual. Same thing with right turn lanes, 14% on one approach, 26% on two. Certainly can improve operations in some cases. I'm going through this pretty quickly, so if anybody wants me to stop, say stop, because I do want to get to the case study. Anybody doing offset left turns?
Yeah.
Lots of this happens at signalized, not so much unsignalized. This was actually the one where I was reading the CMF and got all excited because I thought we had some new information, and then I read the abstract, and at the very bottom it said don't use it for unsignalized. And so this is not in the highway safety manual, but you can see the 78% reduction in left turn and 50%, but just a 2-star, because I think this study actually was Maze's study, which was a high-speed divided situation. So you need to recognize that it's not quite applicable. That's why I got excited about that other information. I thought it was on signalized and maybe not on high speed. Same thing with offset right turn lanes. Anybody doing these? Yeah. In certain places, right? It's important to have because if people are lining up to turn right, you push them back, you improve sight distance, and you get a bit of a 69% reduction in angle crashes. Again, high speed divided situations for that data.
Wouldn't that make it more difficult for the vehicle pulling out? I mean, it looks like you got good sight distance there, but wouldn't it be more difficult for the minor street vehicles to judge gaps when they got, people coming at them, and it's so much wider they got to cross, and they got, if there's a left turn lane, they're trying to.
Right. It does increase the width of it, so that's, it does increase the width of the intersection. It may impact their choices. Yeah.
More sight distance because the stop bar is not as far back. And because the vehicle making the right turn has to commit to that lane, and if they're not using a turn signal, the driver now has a visual cue that they are committed to making the right turn.
Right. And go ahead. So where is the stop bar for the minor street there? Is it prior to the right turn?
So, and this might not be the most proper design or the proper angle of the photograph and everything else, but typically you're going to want them to be able to see here, right? So you're trying to improve the sight distance of the people here. Because you're pushing all those right turning vehicles behind them. Yeah?
Right.
Yeah.
Yes, it's not probably turn.
So it's somewhere in here. And I don't know what's behind the camera at this point.
You also get some conflicts between like a right turner coming here, if there's another vehicle going into the page, turning left, then they're thinking, do I have to yield to this right turner? Does he have to yield to me?
It's all about where your yield signs are and right-of-way rules. And yes, again, it's all I can say is the ones I've seen are not as complicated as we're making it. But pedestrians have to cross a longer distance. There's certainly trade-offs here. Yeah. Goes right into a roundabout. Yeah, it may. It might. Again, it just depends on. It's again hard to tell what we're really looking at here. Yeah. Angle is important. We used to do a lot of this. We'd like to tighten them up a bit, both for pedestrian reasons and visibility. There has been one, and by the way, what's up here is just an example. Then there's the study, and they did a very specific study in Peoria, Illinois, on improving the angle and found these 60 and 40% reductions of all severities. This was for right turn crashes. And the study basically looked at anything that helped with that angle. So this is just an example. They did anything they had to do to help with that angle to do a less head turn and they were trying to also serve trucks better, but it also has an operational impact too. Remember that. It might be safer.
It's also helpful for pedestrians. We're actually currently revising our design manual to go to the best practice element, and there's not a lot of detailed design information out there.
Right, and you're just kind of tightening it up. Because yeah, I know when I'm a pedestrian a lot in high-speed situations out in Iowa. And if I'm on that intersection and I can make eye contact with that person, I know whether they're going to continue through that yield sign or whatever it is. So good stuff. Skew, you got an equation. I wanted to mention this. You might want to kind of maybe even cross this out, because I actually contacted the CMF Clearinghouse people. There is an equation for this, and the one in the CMF Clearinghouse wasn't quite the same as the one that was in the Highway Safety Manual. This is the one that's in the Clearinghouse, and I went back and looked at the Highway Safety Manual, and it was a bit different. They had in parentheses here, for the CMF now, not a CRF because it's an equation, basically the difference was the difference between a 90-degree angle and what you what you had, which is different than a difference between proposed and existing. So there were some assumptions being made. I've contacted the CMF clearinghouse people a lot saying, hey, I saw this. I'm not sure it's quite right. So they've added a note to the CMF clearinghouse as of yesterday on this CMF CRF. Now it's an equation, so they can't rank it. And basically it comes down to about a 10% reduction for a difference of 10 degrees, something like that, if I'm recalling correctly. Let me check. 5% reduction for every 10-degree reduction in skew angle is what that equation represents. Basic set of signing on an intersection. There's the picture that comes out of the intersection low-cost safety improvements at intersections document by Federal Highway, where they said to do this will get you, I believe it's a 40% reduction in crashes. That was a bunch of experts getting together and talking about it. Yeah, 40% reduction. What's in the CMF clearinghouse for implementing systemic signing and marking is a 10% reduction in injuries and a 14% reduction in nighttime, but the basic set is not quite the same. And remember when I made the point of when you start getting into these combinations, you got to pick the one that looks closest to you. Now, the document that was from is from 2009, and the research comes from 2017, and it's a 4-star. So we got to pick one, right, with regard to the basic set of intersection safety improvements. I think the signs that got dropped out from the study here are these two, and then maybe one of these street name signs, and for sure that double arrow. Big signs, big stop signs, 48. Survey study shows 19% reduction in crashes for that. Doubling up stop signs, 55% reduction in angles, all urban. That's a 1-star though, okay? That's a 1-star study. So it's all about what we've got. This is the best I've got for you. 11% reduction in all crashes, but wasn't ranked because it was based on a survey.
Do you have one for rural?
No, not as far as I know. I can check it out for you. Rural two stop signs? Yeah.
Well, because one of our major thoroughfares, we went from a single 30-inch stop sign to a 48-inch stop sign to double 48s to Rickwas. And now a Rickwas with intersection lighting, so I just,
I'll check. Retroreflectivity matters. It's a requirement of the manual and uniform traffic control devices. You've got to do it. There's certain minimum requirements. Plans were supposed to be in place at all levels of government to replace signs that are below a certain amount years ago at this point. So 7.6% reduction in angle, 17.5 reduction in rear end, 4 stars, but not in the CMF clearinghouse again because it's operational.
Are these 6, is there a minimum here that you have to put out there?
Right, so in the manual and uniform traffic control devices, there's a table on the minimum retroreflectivity you have to have on signs. For certain colors, it changes and things like that. So, and you're not supposed to go below that, yeah. But
Is that varied by facility or?
it's been so long since I've taught that.
So
Yeah.
you can't say it's got to be 7 or above. It just depends on your situation,
Right.
what you're saying, right?
Any input on that, Rich? Sheeting wise?
I think it's all,
And it's not engineering
I
grade.
don't know what the numbers mean.
but all I know is gone to the diamond grade, right? Stop signs, yield signs, high intensity on anything else.
And I thought I'd recalled that engineering grade was not, that's not working anymore. It's got to be something above that. So yeah,
We don't allow engineering grade. We're currently
I don't think it meets any of the requirements.
type 8, but we're thinking about raising that up and going to type 11. We're looking at that now.
Yeah, and I know there's Federal Highway website on all that too, on the types and things like that. And I don't know, again, I couldn't tell you the specifics about the study with regard to what number it looked at. And it's just on stop signs. Flashing beacons, they threw a bunch of flashing beacon stuff together and found a 16% reduction in angle crashes in rural areas. And when I see they threw a lot together, it was everything from flashing beacons up here, flashing beacons on the post, flashing beacons, and that's what ended up making it into the highway safety manual, okay? I almost took a picture of one here in Savannah of the flashing yellow in one direction, flashing red in the other direction, because there are states that are now removing those because people drive up on the stop side of it and think it's a flashing red in all directions and pull out. There's been some work in that area, and at least in Iowa, we're now taking out the yellow-red flashers because of that confusion. There's your LED, 41% reduction. I think that's a 2014 study. I think it was out of Minnesota, actually. Replacing a standard sign with the standard LED, stop LED, 3-star. That may or may not make it into the new highway safety manual or not. The warning, the conflict warning systems. Everybody know what I'm talking about there. You tell people whether there's somebody on the other approaches that are conflicting with you and whether you should pull out kind of stuff. Lots of different versions of that. Big reductions in all and angle crashes in rural areas. 5-star studies. Lots of different versions of that where it's telling you to go or not go. So you see a 19% increase down here in all PDOs with regard to transverse rumble strips. Again, all I'm telling you is what the researcher said. The researcher said, well, that's a trade-off, right? Maybe people are doing some weird stuff and there's more property damage. But if your serious injury and fatals are going down by 21%, to me that's a good trade-off. And if you're going to do it in very specific locations, not everywhere, because then people get used to that. And plus there's a noise issue. My recollection is it's not, again, it depends on the design. If it's properly designed, I don't think it's a big issue. Noise pollution. So additionally, one must consider maintenance that is required. Effect on bicyclists. We forgot about the bicyclists or motorcyclists. Some states use these only within the wheel path to provide that situation, let them go through the middle, right? So, yeah, could be. We don't use a lot of them in Iowa. I think we were using them too much, and so we backed off on it.
So what I've done, or what my predecessor installed transverse rumble strips. Set of 3 and then the set of 2 comes to the stop sign. We'll skew them a little bit or shift them a little bit toward the center line. So if people are going to avoid them, they're going to avoid them on the shoulder side of the rumble instead of the center. So
good point, yeah. Shifting them towards the center line so people can go around them. I do have something on lighting. Again, I just put it out there that nighttime impacts are bigger, pedestrians, whatnot. This is, again, they did do a study in Minnesota that it's not on this table about just doing the one light, and that also found reductions in crashes. New Georgia Tech study, good, thanks. I wanted to bring up intersection sight distance. This is brand new. This used to be what it was, 5% if you 5% per quadrant if you made it so there was good safety improvements, right? This is what's out there now. So get NCHRP 875. It's brand new from 2018. And I didn't include the equation of these graphs because it's about this wide, this tall, and that wide. It's stacked. Everybody could apply it. It's just too much. They put it in graphic form. And what you end up doing with the CMF here, total target crashes, available intersection sight distance, is go to the right graphic. You don't have this. I literally added this Friday, I think it was. Each of these curves is based on ADT. You pick the right curve. You go in with your existing sight distance and your proposed sight distance, and you divide one with the other. So existing sight distance should be lower, which means your CMF is higher, and you're going to increase it, and which means it's going to go lower. So you're dividing your proposed by your existing to get a CMF that's below 1, unless you're trying to increase or decrease your intersection sight distance, which wouldn't make any sense to me. So they acknowledge that the equation, no one's going to apply that equation. It is in the CMF clearinghouse, and you can take a look at that equation. But it came out this year, and we've been waiting for this study for 5 years. It's a 46-page report, easy to read, and it has great application-oriented guidance in it. So maybe that's the way NCHRP is going now, because it's really a wonderful study. And I've been waiting, believe it or not, I wait for stuff like this with bated breath, just to hope that it comes out. So 5 years of waiting So any questions on any of this stuff? Here's your pedestrian refuge. We added 3 stars there. Again, big reductions in vehicle pedestrian at marked, unmarked, uncontrolled situations. And we want to do a module, okay? We want to do the last module. We can either do it together and get to lunch. When's lunch? Noon? This has been a long morning. Let's just talk about some of the stuff in the module.